want to identify linear, quadratic, and exponential functions given ordered pairs, and this requires a little bit of intuition and common sense. Linear functions are direct variation problems. So if x increases by 1 in each step, then y is going to increase or decrease by the slope in each step. So I look at the first example, and I have, to get from 47 to 34, I have a difference of 13. And then I have a difference of 11. And then I have a difference of 9. And then I have a difference of 7. That does not meet the requirements for a linear function. In the next example, I have a difference of 8. And then I have a difference of 24. Yeah, that's not going to fly at all. That is not linear. In the next example, I have a difference of -9, and then -9, and then -9, and then -9. Right, to get from 5 to -4, we go down 9. To get from -4 to -13, we go down 9. That is a linear function. So I have a constant change in y for a constant change in x. Now let's go back here and see what we have to say about quadratic functions. Now, the first perfect square, well, 0 squared is 0. And then plus or minus 1 goes to 1. And plus or minus 2 goes to 4. And plus or minus 3 goes to 9. This is a difference of 1, 3, 5. We change by consecutive odd numbers as we move from one perfect square to the other. And that's true even if I shift the quadratic function around the plane, the change will still be some shift of consecutive odd numbers. Now that can be affected by a leading coefficient. So we're looking for a pattern here, either a quadratic function that it gets smaller and then gets larger again, or just a change of consecutive odd numbers. And we already determined that this is a change of 13, this is a change of 11, and this is a change of 9, and this is a change of 7. That is a quadratic function. Here, this is a change of 8, and this is a change of 24, and then this is a change of something huge, whatever, it's not quadratic. Then after we look at the arithmetic difference between them, which is, the sum or difference between the different terms, we're going to look at the ratios. Note that if I multiply 4 times 3, I get 12. And if I multiply 12 times 3, I get 36. And if I multiply 36 times 3, I get 108. And if I multiply 108 times 3, I get 324. That is an exponential function, and 3 is the base. One of the favorite tricks in online learning management systems is to have a 3, a 3, a 3, and then have this number be wrong. So you do have to check all the way down the list before you come to a decision.